This is the video to check for the next entry for the linear programming tableau. Over here on the left, we have the routine to check for the next entry. Over here on the right, we have the Simplex Tableau. It has a row for every part and a row for the margins. First, we start out with a row for the first part that says how many parts are needed for item 1, 9, for item 2, 4, and for item 3, 4. Then the next value is for the identity matrix that is set up for the slack variables. Here is the 1 for this one, followed by 2 zeros for the other two parts, and then followed by the quantity. Alright, this is for the first part. The second part's row starts at offset 30. And it says for the first item you need 2 of this part, the second 8, the third 7, and then the identity matrix is now at the second value under the slacks. The 1 is here. And there at the end is its quantity. Then we go to the third item, which starts at offset 60. It needs 6, 1, and 7, and then it jumps 2 before it has the 1 for the identity matrix for the slack variables, and then the column for quantity. Well, there's also the row for the margins. Here at offset 90 is 8 for the first item, 5 for the second, and 5 for the third. All the rest, for instance, for the slack variables are 0. Now we'll go through the routine. First, it sets the best column to 999, which will indicate that there wasn't a best column. Set the best margin to 0. Our margin value has to be greater than 0. We set J to the margin offset. Well, that's down to this line down here where the 8 is. Then for I of 1 to the offset of the quantity offset, 1 at a time, which means it's going to go through every column but the quantity offset column. And at each column it's first going to say branch if less than or equal matrix value to the best margin. Well, the first one it's going to find is this 8. It checks that against the best margin, which is 0. Oh, well, it isn't less than that, so it comes, or equal to that. So it comes down here and it says set the best column to jth column. Subtract from that the margin offset. Alright, so that's going to make that value, instead of being 90 here, it's going to subtract 90 from it, and it'll be 0 for the first column. Then it sets the best margin to matrix plus J to that value of 8. That's the best one it found. Well, it's going to go around here for every column except the quantity column. Once it gets through the loop, it says, well, if the best column is still equal to 999, we didn't find a good column. In other words, none of our margins are greater than 0. It goes to BM, and that ends it. Well, if it continues on, because it did find a column to bring in, it will set the best row to 999, indicating that it didn't find a row. Well, next it sets the lowest quantity to a large number, because it's going to try and find a lowest quantity value. So it sets J to the quantity offset. Now we're talking about where these 100s are. Sets J to that. It sets K to the best column. Remember, we discovered the best column up here. So we're starting at the top of both of those columns. Then for I of 1, until next I for all parts. Well, that's how many rows are for the parts. We now have the top index value for each one of the two columns. Well, we're going to say branch if less than or equal to matrix plus k. Now that's the best column one, is less than or equal to small. Small is a very small number. If it is, we can't consider it, so we go to BE. Next, we set the quantity to the matrix at offset j. Then we divide that by the matrix offset at k. That's going to give us the quantity change. And then we say if the quantity is greater than or equal to the lowest one we found so far, we're going to go to BE, down here. That one's no better than what we found already. However, if it is better, we say set the best row to the value of I, but then it subtracts 1 from I because we want the offset starting at 0. And if you notice here, I started at 1. So it subtracts 1 from it, so the first one will be at offset 0. Then we set the lowest quantity to that value of Q. So then we go around and around until we find the lowest ratio here from the column that was selected in relationship to the quantities in the quantity column. Well, each time we go around, we're going to a new row. So both J and K have to be increased by 30, the offset for the rows. Then we go to our next I for each part count, so we check every one of them. But if we come down here and find out that the best row is still equal to 999, we go to BM, there's nothing we can do. It's the end of our searching. So this is the routine for check the next entry for the linear programming tableau.